Today we're in the second day of 11.2, and again we're going to use that idea of plugging in values, but we're going to step up the difficulty level just a notch. So again, we're going back to piecewise functions. Again, this is something that's very important in calculus. So here I'm piecing together a quadratic, so I have part of a U shape, and I have a linear, so a straight line. So now we're going to remove the graph from you, and we're just going to discuss plugging these values in using the piecewise function. So for the first one, notice I'm approaching 2 from the left-hand side. So that would mean all my values that are less than 2, which means I'm looking at this top section of the function. So I'm going to plug 2 into that piece. So I'm doing 2 squared plus 5. So 2 squared is 4 plus 5 is 9. Now I know that the coordinate 2, 9 would be open because of the inequality right here. I know 2 is not included. So 2 would be an open dot. So that if you can kind of visualize, I'm approaching 2 from the left, get very, very close to 2, but at 2, 9, it will be an open dot. Now I'm approaching 2 from the right-hand side, so I'm talking about my values that are bigger. So I'm plugging into the bottom piece. So 6 plus 1 is 7, and I know the coordinate 2, 7 will be closed. It will be defined there. So as I approach from the left, I'm going to 9. As I approach from the right, I'm going to 7. So overall, the limit does not exist because these two things are approaching two different values. Now, however, if I asked for f of 2, I know the answer would be 7 because that's where it's defined at. So again, that's the idea of piecewise functions without looking at a picture. So again, let's get into some more difficult cases. So here I have the limit as x approaches 3. So the problem with this is I cannot just simply plug in 3, because if I plug in 3 to the bottom, I get 0, and we know that you can never divide by 0 because that gives you no solution or undefined. So we have to do a little pre-work here. Cannot just plug in 3 simply. So I have to look at this equation, and I got to see if I can somehow cancel out that x minus 3 in the bottom. So in the numerator, we know it's a quadratic. We got to see if it's factorable. So I'm dealing with a negative 6, so I'm looking for two numbers that multiply to be negative 6 and add to be a negative 1. So that combination is going to be a negative 3 and a positive 2. So we know we have x squared minus 3x plus 2x minus 6. We group them, and again, if you're a boxer, those are your 4 terms in the box. I take out an x for that first quantity. I'm left with x minus 3. Second quantity, I can take out a 2. And I'm left with x minus 3. So from here, I say x minus 3 and an x plus 2. Now, if your coefficient is 1, so here the coefficient technically was a 1, whatever your combination will always be the answers. However, you can only use that shortcut if the coefficient is 1. If the coefficient is not 1, that rule does not apply. Now, to kind of go back into the problem, the top factor is to be x minus 3 and x plus 2. And we know it's being divided by an x minus 3. So I can cross out a set of x minus 3's. So now the problem is the limit as x approaches 3 of the quantity x plus 2. So when I plug in 3, the answer is 5. So I would say that this is that's a small step up as far as difficulty level, but again, it's just going back to a lot of basic algebra 2 skills. So let's do one more for today. This will probably be the most difficult one. So again, if I were to plug in 0 right now, in the top I would be good to go, in the bottom I would get no solution because I have that x there. So we're going to do the whole idea of rationalizing by multiplying by the conjugate. Except we're multiplying by the conjugate of the numerator, but you can always do that. So as long as I multiply the top by something, I have to multiply the bottom by something to kind of keep our fraction equal. So in the numerator, you're essentially foiling or boxing or distributing. So I know that first term is going to be the quantity of x plus 4 squared. So it's a square root of x plus 4 times the square root of x plus 4. Therefore, it's squared. Inner and outer are going to cancel. I would have 2 square root x plus 4 minus 2 square root x plus 4. and then I have minus 4 all over, and I'm just going to leave this x out there in the front. I'm not going to multiply that in. So these terms right here are going to cancel. I have one positive, one negative. And on the left-hand side, a square root and a square root are going to cancel. So essentially now we're at this step here. I have x plus 4, because that square root canceled right here, minus 4, all over x times the square root of x plus 4 plus 2. And in the numerators, I have a 4 and a negative 4, so again, these can cancel. So with those 4's crossing out, now I'm at this step. At this point right now, if I plug in 0, again, I would get 0 divided by 0, which would be no good. But I'm going to look at this and say, okay, well, I have a 0 top, and I have not 0, we have an x top and an x in the bottom. So I can kind of reduce that fraction by a unit of x. And now when that cancels out, I need a placeholder for the numerator, so I have 1 over the square root of x plus 4 plus 2. And now at this point I've simplified everything that I can do. Now I want to plug in that 0. So I have 1 over the square root of 0 plus 4 plus 2. So I would have the square root of 4, which is 2, plus 2. So the limit is approaching 1 over 4. And that is the final answer for that problem. So like I said, this one is a little bit more involved. This is probably the most difficult one you would see in this section. And again, we're going to do a lot of practice on these types of problems tomorrow.